Welcome to This Day in His Story, created by American Heritage Worldwide. A reminder that every day holds something new to learn. Did you know that in 200 BC, sundials correctly told the time of day within 15 minutes? Join us as we learn how railroads change time for all of us with a standard system of 4 different time zones. Do you know what time it is?
When was the last time you asked what time is it?
It's such an automatic thing now, isn't it?
It is. You pull out your phone and the answer is right there. It's synchronized, it's global, precise. But if we rewind the clock a bit,
Unintended.
pun fully intended, for most of history, that answer was, well, it was intensely local. It was only really true for you and maybe your closest neighbors.
And that's really the core of what we're digging into today. We take this global standard completely for granted, but it's one of the most remarkable organizational feats of the industrial age.
So that's our mission for this deep dive then.
Exactly. We're going to unpack that huge, rapid shift from a world where time was just based on the sun to one governed by international law, all using the source material that traces this journey.
Okay, so let's start with that before state. To really get how big a change this was, we have to understand what it replaced. For millennia, time was all about the sun and the stars.
Right. And civilizations got really good at it. You had sundials as early as 200 BC, and they were, for their context, incredibly accurate.
How accurate are we talking?
Well, the source material notes they were correct to within about 15 minutes.
Wow. Within 15 minutes, just from a shadow.
Yep. They were set up so that noon was the exact moment the sun was highest in the sky when shadows are shortest. That's local solar time. But that system had a huge built-in flaw for anyone trying to travel.
It's the local part of local solar time.
Precisely. It all depended entirely on your longitude, your east-west position. The math is pretty simple, actually. The Earth turns 360 degrees in 24 hours.
Okay.
Which means every single degree you move east or west changes your local solar time by 4 minutes.
4 minutes for just 1 degree. So moving just, 15 miles or so would put your clock off by a whole minute compared to where you started?
Exactly. And as long as communities were pretty isolated, our sources say this was, and I'm quoting here, of little consequence to local businesses.
Sure, the blacksmith doesn't care what time it is in the next state over.
Right. But then, in the early 19th century, you start getting these really well-regulated mechanical clocks.
Mm-hmm.
And suddenly, people realized their very accurate clocks didn't agree with the clocks in the next town over.
And that disagreement became a crisis when a new technology showed up.
That's the conflict. It wasn't a philosophical problem anymore. It was a practical one, a huge one.
Okay, let's get into that catalyst, because this is where it gets really interesting. The whole system was forced to change not by an idea, but by sheer speed.
It was all about the steam engine. February 28, 1827, the Baltimore and Ohio Railroad starts replacing horse-drawn carts.
And the world just shrank.
It shrank dramatically. Journeys that took days could now be done in hours. You could move huge amounts of raw materials, people, everything from state to state so quickly.
But that created a massive paradox, right? The very speed that was their advantage also made scheduling almost impossible.
It was chaos. And it was dangerous. Think about it. If every town on the line is running on its own local time, which is a few minutes different from the last one.
How do you even create a timetable? How do you know when a train is actually going to arrive? Or if another train is on the same track?
You don't. You simply couldn't know if the 1.0 p.m. arrival was based on the local time or the time from the town it just left. It was an absolute commercial and safety necessity to create a uniform system.
So the industry that created the problem had to be the first one to solve it.
They had to. The railroads couldn't wait around for governments to debate it. So they imposed a standard themselves.
And that happened on a specific day, November 18th, 1883.
That's the date. America's railroads all agreed together to stop using local solar time. They just switched over to a standard system with 4 time zones.
Our time zones, basically. Eastern, Central, Mountain, and Pacific.
The very same ones. They just laid them over the whole country and its territories. And what's so fascinating is how that one industry action in America immediately pushed for a global solution.
Because it proved it could be done.
It proved it could be done. The very next year, 1884, they create an international system.
So that leads to the big meeting in Washington, D.C.
The International Meridian Conference, yep. Delegates from more than 24 nations got together. Their biggest problem was agreeing on a starting point. A point zero for the whole world.
And this is where a key figure enters the story.
A Canadian, of all people, Sir Sanford Fleming. He was a railway surveyor and engineer, so he knew the problem inside and out.
And he had the solution.
He was the one who suggested using the longitude line that runs through the Royal Observatory in Greenwich, England, as the official prime meridian.
So you have a Canadian engineer at a conference in Washington, D.C., picking a spot in England to create a time system for the entire planet, all because of trains.
It's a perfect example of global cooperation driven by commercial need. But even then in the U.S., it was still just a railroad standard. It wasn't yet federal law.
And that took a while longer.
Decades, actually. It wasn't until 1918 that the U.S. government passed the Standard Time Act.
Which finally made the railroad zones the official legal time for the whole country.
Right. And interestingly, that same act also introduced something else.
Daylight saving time.
Exactly. The law required moving clocks forward an hour in the spring and summer and gave the Interstate Commerce Commission the power to define and regulate the time zones.
So let's break down the mechanics then. We have the history, we have the law. How did they actually divide up the world so cleanly?
The geography is actually pretty elegant. A time zone is just a region of the Earth that's bounded by meridians, those vertical longitude lines on a map.
And we know the Earth is 360 degrees. So how do you get 24 clean 1-hour zones out of that?
You just do the math. You take 360 degrees and you divide it by the 24 hours in a day.
And you get 15.
You get 15. So the meridians that define the time zones are said 15 degrees apart. And since we already said 1 degree equals 4 minutes of time.
15 degrees times 4 minutes is 60 minutes? 1 hour?
It's a perfect 1 hour difference per zone.
Yeah.
It's so clean.
It really makes global travel, or at least scheduling it, so much simpler.
Immensely simpler. Anyone who's flown long distance knows the rule, even if they don't know the math behind it. You travel east from Greenwich, you add an hour for each zone.
And you travel west, you lose an hour.
Right. And by the middle of the 20th century, pretty much the whole world had adopted this system for, all commercial, legal, and social purposes.
So we've spent all this time on time as this external thing defined by maps and commerce and law. But the source material you brought also asks us to kind of pause that and think about time differently.
It does, and I think it's a really crucial pivot. Standardized time is all about efficiency and external demands. But the other source, from Elder Ronald A. Rasband, shifts the focus from mechanical time to internal time.
He talks about taking time to listen to the spirit.
Yes. It's a powerful contrast, isn't it? The railroads force us all to sync our watches to this one global clock. But this other perspective asks us to schedule time for something internal, for quiet guidance.
It sort of challenges the whole idea that every minute has to be productive in that commercial sense.
It really does. He shares that the best way he hears promptings is by deliberately setting aside time to read the scriptures and then acting on what he feels. It's a kind of intentional, personal timekeeping that has nothing to do with those 15-degree zones.
Which brings up a really good question for you, the listener. We put so much energy into optimizing our schedules to meet these external demands, the very reason time zones were invented. But how often do we schedule time for that internal reflection?
Yeah, it's a great question. How often have you really just taken the time to listen? When time becomes just a number on a clock, a commodity, it can feel depersonalized. This source is a reminder that the personal value of time isn't always about speed or efficiency.
It's about the stillness you create.
The stillness you create to get your own direction. It's such a striking contrast to the speed of that 1827 steam engine we started with.
So to recap our whole journey here, we went from local sun-based time, which was surprisingly accurate,
to the chaos of the railroad age, which forced the U.S. to standardize time in 1883, and then the whole world just a year later.
all based on that elegant math of 15 degrees of longitude per hour, an idea pushed by a Canadian surveyor and finally made into U.S. law with the 1918 Standard Time Act.
This deep dive really shows how necessity, in this case the need for travel and trade, forced this incredible global synchronization.
So as we wrap up, let's leave you with that personal challenge. You've heard why time zones are essential for, catching a flight or scheduling a meeting. But why is it important for you to know what time it is beyond all those coordinates and commercial needs?
Yeah, think about the rigid mechanics we discussed, those 15 degrees of longitude, and then contrast that with the importance of taking quiet time to listen and reflect. What's the real value of time that you can't measure in degrees or hours? Maybe share some of those thoughts with a friend or family member this week.
Thank you for joining us for this day in His story. May the lessons of yesterday inspire you to see God's hand today and to play your part in His story now. To learn more, visit ahsworldwide.org. worldwide.org.